A quick recap of shared responsibility prevents confusion later. Cloud providers secure the physical facilities, core infrastructure, and native service resiliency. Customers are accountable for secure configuration, identity, data protections, and operational monitoring. Your SOC 2 system description should draw a bright line around this delineation, mapping controls to the responsible party for each provider. For example, while AWS ensures the durability of S3, you must configure bucket policies, encryption, and lifecycle rules. Azure guarantees host hypervisors, but you must manage NSGs, Key Vault, and logging. GCP protects the fabric, while you define IAM, VPC service controls, and CMEK. Provider assurance reports validate their side of the bargain. Your evidence proves you executed yours consistently. Account and identity governance are the first pillars to harmonize across clouds. Require SSO and MFA for all console access, root, owner, and admin alike. And federate identities from a central provider so joiner, mover, leaver events propagate automatically. Standardize patterns for privileged roles and service accounts, short-lived, scoped credentials, workload identities that avoid long-lived keys, and clearly separated break glass access with enhanced logging. Regularly audit IAM activity logs for anomalous grants, unused roles, and privilege creep, and document remediation. By making identity the uniform control plane for AWS IAM, Azure Entra ID/role assignments, and GCP IAM bindings, you transform a multi-cloud sprawl into a single, measurable access story for auditors. Network security must follow a portable blueprint that adapts to each provider's primitives without changing intent. Define a baseline that minimizes public exposure by default, uses private subnets and managed ingress, and applies least privilege routing between tiers. In AWS, that means route tables, security groups, and VPC endpoints. In Azure, VNets, NSGs, and private link. In GCP, VPCs, firewall rules, and private service connect. Layer managed web application firewalls where appropriate, and codify inbound rules so variances are explainable exceptions, not accidents. Validate the estate continuously with policy scanners that compare actual configurations to your design standard, and preserve violation and remediation logs as evidence of operational vigilance. Encryption management is a common denominator that auditors will scrutinize for consistency. Use each platform's native KMS with customer-managed keys, enforcing TLS in transit and strong encryption at rest for all storage services. Document how you manage keys across providers, who owns them, where rotation is defined, and how you monitor usage for anomalies. If you support BYOK, specify the import, rotation, and revocation processes and capture approvals and rotation proofs. Align key policies with identity federation so application workloads get only the grants they need, and record KMS audit logs centrally. When encryption practice looks the same in S3, Azure Storage, and GCS, policy, process, and proof, you reduce the cognitive load for both engineers and auditors. Logging and monitoring parity turn 3 telemetry streams into one observability narrative. Enable provider logs at the tenancy and service layers, CloudTrail/config/guard duty in AWS, Azure Monitor/activity logs/defender in Azure, and Cloud Audit logs/security command center in GCP, and forward them to a central CM. Standardize retention, parsing, and alert severities so an access anomaly in one cloud is triaged exactly like the same event elsewhere. Correlate cross-cloud incidents with common entity models, user, role, resource, tag, and keep retention policies aligned so investigators can pivot seamlessly across time and providers. Your goal is not just more logs, but comparable signals with shared playbooks and clean evidence exports. Configuration compliance should be continuous and automated, not a quarterly scramble. Deploy Cloud Security Posture Management Tools, CSPM tools, or native policy engines to scan accounts, subscriptions, and projects against your baseline. Detect drift in near real time, auto-remediate low-risk misconfigurations when safe, and create tickets for higher-risk items with tracked SLAs. Capture daily or weekly evidence snapshots of posture results and remediation histories to satisfy sampling during the audit period. Over time, these artifacts show a pattern of control operation, finding, fixing, and preventing recurrence, rather than static screenshots that age out the moment they're taken. Segregating access by environment reduces blast radius and clarifies evidence scope. Use separate AWS accounts, Azure subscriptions, and GCP projects for development, testing, and production paired, with dedicated networking, KMS keys, and role boundaries. Monitor and restrict cross-environment access paths and require change approvals before promoting artifacts into production. Maintain environment-specific evidence logs, screenshots, and exports so auditors can sample production controls without wading through lower-tier noise and still verify that non-prod adheres to the same guardrails. Clear boundaries shorten investigations, simplify sampling, and reduce the chance that a helpful dev shortcut becomes a production incident. Cost and resource tagging are not just for FinOps, they are the backbone of compliance scoping. Establish a cross-cloud tagging standard that includes project or system name, owner, data classification, environment, and criticality. Enforce tags at provision time through policies and pipelines so resources cannot launch without required metadata. Use tags to scope evidence, e.g., all prod plus confidential resources, and to detect shadow environments or orphaned assets. Export tag inventories regularly and preserve them as audit artifacts that corroborate your population samples. In multi-cloud settings, good tags are the glue that holds identity, encryption, logging, and backup stories together. Availability in multi-cloud is earned through thoughtful resilience patterns, not only provider breadth. Deploy workloads across multiple regions within a provider where practical, with health-checked failover and replicated state. Where cross-provider failover makes sense, pre-provision minimal landing zones and data replication paths so recovery is minutes and hours, not days and weeks. Backups should be automated, encrypted, and tested per provider, with restoration metrics captured and trended against RTO/RPO targets. When you can show repeatable DR tests in AWS, Azure, and GCP with evidence of restore times and data integrity, you satisfy the availability category with proof rather than promises. Provider assurance reports complete the shared responsibility story. Collect and catalog the latest SOC 2/ISO attestations for AWS, Azure, and GCP, noting coverage of security and availability domains and any carve-outs that affect your design. Track review dates, findings, and bridge letters to maintain continuity across audit periods. Reference these documents in your system description and vendor management files so auditors can see how you validated the provider side while designing compensating controls for any gaps. These artifacts demonstrate diligence. You trusted but verified, and where needed, you adjusted. Finally, make automation pipelines the enforcement arm of your multi-cloud baseline. Use infrastructure as code, Terraform, CloudFormation, Bicep/ARM to stamp consistent networks, identities, logging, encryption, and tags across providers. Add policy as code guardrails that block non-compliant resources pre-deployment, and integrate with CI/CD to run compliance checks in pull requests. Log pipeline outcomes, policy denials, and exceptions with approvals, and keep those logs as evidence of preventative control operation. Automation doesn't just speed delivery, it converts design intent into reliable, testable configuration and leaves an audit trail proving that controls were enforced before anything reached production. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Once multiple clouds are active, harmonizing policy across them becomes the only sustainable way to maintain order. Cross-cloud policy harmonization ensures that every environment, AWS, Azure, or GCP, operates under the same baseline expectations for tagging, encryption, and identity controls. A unified multi-cloud control baseline should be published internally, outlining mandatory security parameters and evidentiary checkpoints. Enforcement can then occur through policy as code tools like Open Policy Agent, Azure Policy, or Cloud Custodian, which continuously check configurations against your approved standards. Reducing variance across environments doesn't just simplify administration. It provides auditors with a clear, repeatable story about how governance is applied equally everywhere, regardless of the provider. Third-party integrations expand your risk surface and deserve equal scrutiny. Continuous integration tools, monitoring platforms, and data analytics services often bridge multiple cloud environments. Each of these integrations must follow least privilege access principles and undergo vetting similar to any core system. Credentials for automation services, connectors, or monitoring agents must be scoped tightly and rotated regularly. Maintain an inventory of all connected third-party services and ensure logs capture every cross-platform API interaction. Monitoring these connections is crucial since an overlooked pipeline or shared secret could compromise multiple environments simultaneously. By auditing integrations continuously, organizations prevent their multi-cloud strategy from becoming an attack multiplier. Metrics and key risk indicators translate the complexity of multi-cloud security into measurable performance indicators. Track the number of misconfiguration alerts identified by your CSPM tool each month, and trend the average remediation time for those findings. Monitor the percentage of accounts or subscriptions with MFA enforced and alert on any exceptions. Keep a tally of cross-cloud incidents, unauthorized access, drift events, or log gaps, and record closure rates to demonstrate responsiveness. These metrics help prove to auditors that controls operate continuously, not only at audit time. They also enable management to focus resources on areas where systemic weakness, such as inconsistent logging or key rotation, causes recurring exceptions. Evidence expectations in a multi-cloud audit are broad but manageable when standardized. Cloud Security Posture Management (CSPM) reports serve as primary artifacts for configuration and drift monitoring. IAM audit exports confirm that identity controls were properly enforced, while encryption settings and key rotation logs verify confidentiality protections. Disaster recovery test results and regional failover metrics demonstrate availability resilience. Finally, provider SOC 2 assurance letters and bridge letters close the loop on the shared responsibility model. When these artifacts are consolidated and labeled by platform, the evidence package tells a cohesive, multi-provider story. Controls are consistent, tested, and traceable across the entire environment. Strong governance and ownership transform a complex environment into a coordinated program. Appoint a multi-cloud program lead to oversee all platform-specific control owners. Each provider, AWS, Azure, and GCP, should have designated owners for IAM, encryption, logging, and DR testing. Quarterly reviews with the Security or Compliance Committee ensure that the multi-cloud posture remains aligned with evolving business and audit requirements. A centralized control register tracks each platform's controls, evidence, and responsible parties, maintaining clarity and accountability. With this governance structure in place, every audit finding or remediation task has a clear owner and documented path to closure, proof that oversight extends across clouds, not just within them. Common pitfalls in multi-cloud SOC 2 programs often stem from inconsistency rather than negligence. Security teams may enforce different password or key rotation schedules per provider, creating gaps auditors will quickly find. Overprivileged service accounts are another frequent issue, particularly when pipelines span multiple clouds. Some organizations also overlook log retention parity, keeping 90 days of logs in one cloud and 365 in another, which complicates investigations. The remedy lies in harmonization and automation. Enforce a single retention baseline, automate IAM reviews, and ensure all pipeline credentials are short-lived and scoped. By designing controls for uniformity and repeatability, you eliminate complexity as a source of audit risk. Cross-framework alignment ensures that multi-cloud evidence satisfies multiple standards simultaneously. Controls implemented for SOC 2 can often map directly to CIS benchmarks and NIST SP 853 requirements. Likewise, cloud-specific guidance from ISO 27017 can reuse SOC 2 encryption, access, and monitoring evidence. Maintaining a cross-cloud mapping matrix allows teams to demonstrate how one control meets several frameworks, reducing duplication and auditor confusion. Consistency across frameworks strengthens the organization's compliance posture and provides a unified language for discussing controls with regulators, auditors, and customers alike. Multi-cloud maturity is measured not by the number of clouds in use, but by the coherence of their compliance story. Training and enablement give engineers the confidence and discipline to maintain compliance under pressure. Every cloud provider's security model is different, and engineers must understand how their daily actions translate into audit evidence. Training should cover each provider's IAM, encryption, and logging architecture, as well as how to export relevant evidence during audit cycles. Cheat sheets or quick reference guides can save hours during fieldwork preparation. Tabletop exercises simulating cross-cloud incidents, such as a compromised account spanning 2 providers, reinforce response coordination. Tracking completion metrics quarterly demonstrates that cloud teams are not only trained, but also maintaining a learning culture that supports compliance. Automation maturity determines how efficiently your organization maintains control alignment at scale. The journey typically begins with manual checks of individual provider dashboards. Over time, scheduled CSPM scans and alerting automate much of the verification process. As maturity increases, organizations implement continuous remediation pipelines that detect and correct drift within minutes. The most advanced programs operate predictive compliance dashboards that forecast potential misconfigurations based on change history and policy trends. Automation maturity isn't about technology alone. It's about proving that compliance and security are woven into every phase of operations, automatically monitored and continuously improved. Continuous improvement keeps the multi-cloud control program from stagnating. After each audit, review metrics, findings, and lessons learned to refine controls and automation guardrails. Close findings quickly and incorporate them into updated templates, Terraform modules, or CI/CD policies. Evaluate new services released by AWS, Azure, or GCP for potential compliance impact and adapt standards accordingly. Cross-team retrospectives allow engineering, compliance, and security teams to share discoveries and streamline processes. This cycle of reflection and adaptation demonstrates to auditors that your SOC 2 program is dynamic, not static, an evolving ecosystem of control improvement and operational maturity. Centralized evidence governance ensures that your audit readiness remains consistent across all platforms. A single repository should hold all cross-cloud evidence, with metadata fields identifying platform, control category, and audit period. Retention schedules and review cadences must be automated so that artifacts are never lost or outdated. Immutable storage guarantees that evidence remains unchanged throughout Type 2 audit periods, protecting the integrity of long-term records. By enforcing a unified repository and governance structure, you eliminate fragmentation, ensuring every control, regardless of where it lives, has an auditable, verified trail that satisfies SOC 2's documentation and availability requirements. In summary, a mature multi-cloud SOC 2 program blends standardization with flexibility. Harmonized control patterns across AWS, Azure, and GCP make evidence gathering seamless and predictable. Automation ensures consistent configuration and monitoring, while governance keeps ownership and accountability clear. Metrics provide visibility, and continuous improvement ensures controls evolve alongside cloud services. The result is a resilient, audit-ready ecosystem that meets security, availability, and confidentiality objectives without sacrificing agility. In the next episode, we'll extend this conversation to mobile environments, exploring how mobile app SDLC and release governance bring the same rigor of control assurance to the edge of user experience.